I am going to be starting up the virtual star party in a second, just waiting for Gary, Gonella, and Roy are going to be joining us. We got Phil and Pamela and John Boise, and Mike Phillips is here, although he doesn't have any seeing. We've got, let's see, who else we got?
So you're still showing as limited.
So I've put this live, so this will give people a chance to sort of join us. And there's Roy. And I'm just going to put the view onto Roy. So we're now live to the public. Not that anybody's watching.
Can you share the embed code? I'm having the worst time with...
Sure.
I don't know why Better Hangouts doesn't like me tonight. Or ever.
I'm back, and I think I may have fixed my microphone issue.
Oh, great.
Is that... Can you confirm that?
I can confirm that I don't hear an echo.
Excellent.
Yeah. All right, I'm just going to give you this embed code, Pamela.
Thanks.
And and then I will start to explain everything it is that we're seeing. Uh-oh. There's David.
Hi.
Hi, David.
Hi. Is my microphone all right now?
Yep.
Yeah.
Great, thanks.
Yeah, that's good. We're just waiting for Gary. But I think if people can see now. So if you want, everyone can share this and embed it and +1 it and whatever you need to do.
Yeah, I think I figured this out.
Okay, good. So David, I'm hearing a lot of mic noise there from you. I'm gonna mute you, or you might want to pull your microphone a little bit back from your face. So what have we got? We got room 1, 2, 3, 4, 5. 7, 8, okay, we got one slot left for Gary.
Is that any better now?
Have you got your second stream, Gary?
It's coming up right now.
All right. Oh, I'm hearing an echo again.
That's Cory.
Oh, it was probably your second stream.
Yeah, but there's not even speakers hooked up to the second screen.
Oh, it was probably yours. Oh, Cory, it's you.
I see the microphone popping up on Cory's.
Yeah. Sorry, Cory, I had to mute you again. Okay. If anyone can see this. I don't see any comments yet. I don't know if it's the one.
I haven't tweeted it yet. Here's the Cosmo Quest. I'm going to retweet that.
Okay.
And then I will...
We have someone on Twitter already acknowledging it. Julie
Okay.
K. Frey is out there watching.
Okay, great, great. I'm going to mention it on the Twitters as well.
And we got one other scope or two others besides me?
Yeah, we've got a total of 4 telescopes right now, I think. 1, 2, 3, 4.
If we need another spot, I could drop my video and go on audio with just the scope one.
I'm wondering if Roy can't get in. Are we 1, 2, 3, 4, 5, 6, 7, 8, 9? Yeah, we're full up.
Okay, I'm going to drop my, you don't need to look at me anyway.
Okay.
We got 2 more experts than the expert.
So I don't know what's on the big screen for people out there in the audience, but We have a bit of the moon. We have Mars showing off one of its polar caps quite beautifully, and we have Andromeda,
Yeah.
which, if you could see all of it, is, I think, 3 lunar diameters across. It's a huge object, so this is why we only see the core.
And we're missing Roy. I think Roy had to drop for a second. Yeah, okay, Roy should be back in a second. 4 telescopes.
And we are happy to answer your questions, so you can either tweet to us using the hashtags #CQX space #Hangout, or you can talk to us through the Google Hangout comments. So join in, and we're here to help, and we're here to show you the universe.
So, okay, so hi everyone. So Fraser here. So what we've got is tonight, it's our next totally experimental virtual star party where we've got a total of 4 telescopes tonight. We've got Roy Salisbury, and Roy, you're in Arizona, I believe, with your super cool observatory in the middle of the desert. And right now you're viewing the moon, which so this is Roy's view of the moon. Now you can actually zoom in a bit on the moon, right?
Yeah, I can zoom in to wherever we need to go.
Wow. So like there we go.
Oh, whoa.
Nice. And so what's your setup, Roy?
This is on a Celestron 8-inch with a DSLR camera going directly into prime focus.
Hold on. Sorry, I'm gonna have to mute David there. Yeah. Okay.
I believe the area that's currently drifting off the screen is the Mare Nectaris region of the moon. So we're currently drifting through some of the beautiful, highly cratered older parts of the moon towards the Ptolemaeus area of the Highlands.
And then the next one we've got here is we've got Gary Gonella, and he's got his 14-inch telescope with, we've described this the other night. He's got quite a setup. He's located in the Los Angeles area, and he's got this, which has very poor seeing, and so Gary's got this 14-inch telescope with the normally with a 14-inch Celestron, the view comes out the back of the telescope, and in Gary's case, he's actually got his camera equipped on the front of the telescope, which allows him to get a very wide field of view. And so Gary's showing Andromeda right now, the Andromeda Galaxy, and you can see the dust lanes in Andromeda there. You can see the satellite galaxy on the right. Just beautiful. Now Gary's doing a 1-minute exposure. Now, are you able to talk to us, Gary? Or are you only able to type to us? He had another setup, but we got full, so he had to move out. But he's still got the actual view from his telescope. And then we've got David Riley, which I believe David's in the UK right now, right, David? No, I guess he can't. I might have muted him.
Can you hear me now?
Yeah, we can hear you.
Okay.
So have you got Mars there?
Yeah, that's right.
Oh, it's beautiful. Is there a way? It looks a little bright. I don't know if you can tune it down a little bit.
Yeah, I'll try and do that. I'm not sure if I've got it really well in focus either.
Yeah. And then, and last but not least, we've got Cory Schmitz, who
Do you want
has
me to try and zoom this view in?
whatever you want to do to get the best view possible. And then Cory
Maybe
Schmitz
try it.
is where are you, Cory? I don't know if you can hear us. So he's got a view of the moon, but unlike Roy's view, he's actually zooming it around manually. So it's pretty crazy. So he's actually like moving it around and keeping the moon in the field of view. So there we go. So let's see. Does anybody want to focus on anything? Do we want to look at anything? 4 telescopes.
I love this view of Mars. it's fuzzy, but you know, Mars is only a third of the size of the Earth. It's only 4,000 kilometers across, something like that, 3,000 miles across. And it's right now it's 74 million miles away, 120 million kilometers away. It's a long way off for a dinky planet, and there it is. Look at it; it's orange, and that's rust. I mean, there's iron oxide in the sand, in the dust on the surface, and you can see the polar cap. I'm not sure which one that is. And every now and again, if you watch it, every now and again, the image steadies up, and you can see right in the middle there's a dark spot. That's some sort of surface feature, probably what, Syrtis Major.
Yeah, so that's the north.
Mike, you have your Mars globe there, right?
Yes.
I would think that's the north.
It's the North Polar Cap,
I
and
thought I had the camera the other way around.
it's springtime in the northern hemisphere, which I'm upside down, right? So it's actually this way.
That's really great. You can definitely see. I'm not sure if the people who are actually watching this can actually see the view of the polar cap, but I can definitely see it in the view. Now Mars is closing in on opposition, isn't it? And so we've got a little bit more color commentary here as well. So we've got, of course, Dr. Pamela Gay, my co-host on Astronomy Cast. We've got Dr. Phil Plait, the bad astronomer. We've got John Voisey, the angry astronomer. We've got Mike Phillips, who is usually one of our telescope operators, but has some bad seeing and some misbehaving technology. So instead, he brought props tonight, which I think was very thoughtful of him. And then we've got Chris Christopherson is another one of the astronomers, but you've got bad seeing as well, right? Oh, he's muted himself.
Yes, I have bad seeing in a muddy yard, so.
A muddy yard, yeah. Yeah, the telescope would sink out into the, into the mud.
Yeah.
Awesome. All right. Cool. So
To
I don't know.
answer your question, Fraser, Mars is at opposition in March.
Yeah.
And that's when it's opposite the Sun, and so that's when it's as close to the Earth as it gets for the year, roughly.
That's really cool. And has somebody brought a map of the moon so we can know what we've got? Roy's view. Look at that wall, mountains.
Those the Apennine Mountains.
There you go. He's zoomed
Sideways,
out.
I've got
Yeah,
Zoom
one
out
of the
so you
things
can see where you're looking.
Yeah, one of the things that's really important to know is that the configuration that we see of every object can be completely different depending on where people are in the world, even just the way the camera is connected to the telescope, right? If you connect the camera sideways or upside down, then you're going to see a view that's upside down. Also, many telescopes will flip the view. So there's no sort of up or down, right or wrong here. But that's just beautiful.
Yeah, I was always wondering what that was, because on the CosmoQuest on the moon mappers, I haven't yet run across one of those yet. So maybe Pamela could tell me what I was looking at.
So on CosmoQuest, we were actually really picky about what regions that we were using initially, because we want to make sure that everyone's doing everything right as we check our software. So currently the regions that are in the system are some of the most well-studied regions of the moon that allow us to calibrate the system. So we're looking at the areas around the Apollo 15 landing. And then there's also regions in there that are of particular scientific interest to our scientists, Stuart Robbins and Ariana Antonenko and Clark Chapman. And none of them are interested in mountains. So right now we don't have any mountains or any faults in our images. That'll change over time as we bring in more scientists with more things they want to study.
I actually believe I'm here now.
Hey, we can hear you too and talk to you. That's amazing.
If the headset isn't plugged in when you start the session, I can't plug it in afterwards and get audio.
Oh, okay. Well, no, it definitely works, so that's great. It's fantastic. Okay. And so we're going to switch. Man, look at that moon, though. I don't want to stop looking at that. Man, that's just amazing.
I'm pretty sure that's the edge of Mare Imbrium, and that's the Apennine Mountains. But I'm not 100% sure. That would make that crater Archimedes, that big one at the bottom left.
And then Gary, you've got your view of Andromeda again, which is just fantastic. Look at that.
That's a 30-second exposure at the moment.
Wow.
Goes out a little bit.
That's fantastic. Did you want to? So what else is up for you tonight then?
Quite a bit. I can go over to M1. We didn't get much on that the other night. So let me.
And
let me
M42
slow over there.
Okay.
Yeah.
I don't know if you can show off your cam of your telescope slewing.
Yeah, I gotta find it here. It's under too many windows.
I always ask for this because it's always so cool. So you can see his setup. He's actually got a camera pointed at his telescope. And so then where's everybody located? Let's see. So I'm on the West Coast. Gary's on the West Coast as well. So he's seeing some of the stuff that's just after the sun has gone down. I guess next over, Roy is located. I'm not sure where Cory's located actually. Roy is in Arizona, so he's sort of another time zone over, and then David is actually in England, so he's going to see Mars a lot higher up in the sky than it is right now. And so if you go outside right now, depending on where you are, if you can see the moon, you can probably also see Jupiter. You can also see, Orion will be up. Mars comes up around 10 o'clock at night for you. Saturn isn't up until probably 1 in the morning. So unfortunately, we don't have anyone
Venus
in
may
that.
still be up for some.
I don't know. So David, can you try and get Saturn in view?
Yeah, I'll have to try that. I can
That'd
see
be
it
great,
now.
thanks.
It's only a little way above the rooftops.
That would be great.
And if you can get Eris still, I don't know if it's starting to get too low. It's in the constellation sextants right now. I
Just
can
one
drop
at
a finder into
Just one at a time. Roy will probably be able to do it, although. Yeah, that would be great, Roy. Thanks. And that way we've got Cory's on the moon. You can be on. So Roy's going to switch over to Jupiter, and we've got Gary on M1. There it is. This is.
I'm going to move to Saturn now.
That would be great. Thanks. Well,
my wireless camera in the pod doesn't seem to want to connect right now.
Oh, okay. All right. No problem.
So it's being cranky.
Yeah, we've got a really cool view that we can see of Gary's camera, of Gary's telescope slewing over to look at the object. So M1, does anybody know what this is? Anyone? Any astronomers there? Anyone with a PhD, please?
Ouch.
Go ahead, Pamela. You studied cataclysmic white dwarfs, right? I'm the one who studied supernovae, so.
So you're going to give, I have to admit, I was doing is that a supernova remnant or is that a planetary nebula? It looks like a supernova remnant, but I don't want to screw up.
It's the Crab Nebula, M1.
It's tiny. Okay,
That's because Gary has got a telescope that shows like the whole sky at one fell swoop.
Look at that.
That is really fabulous.
Here, that a little more gooder?
You have prominently embiggened it.
Yes. Yes. No, that's quite fabulous. So this is actually the gas and dust that used to be the outer parts of a ginormous star that opted to explode when it ended its life. And it sprayed the material outwards, and as the material moves, it's interacting with the interstellar medium around it. And what's really amazing is we can look through images of this object that have been taken, well, since cameras were first invented, and we can measure the rate at which this object is expanding into the space around it over time.
Yeah, you can blink images, and you can see those tendrils. As the material expands, it gets compressed. There are shock waves bouncing around inside of this thing, and as this stuff expands, you get those filaments and tendrils. They're very sharp features, and so as this thing is expanding, you can take pictures of it. There's pictures from the 1950s. You can compare to 50 years later, and you can blink them back and forth, and you can see this thing going boop, 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 getting bigger and smaller. I actually wrote based on an old exercise, I wrote an educational activity where you measure you pick a bunch of spots, you measure how much they've moved, and you compare that with some other knowledge we have about the nebula, and you can actually calculate how old it is, when this thing exploded, and the number you get is very close to the correct answer, which is year 1054 AD. Whoop. And if you're listening, and you're not seeing the Crab Nebula now suddenly, we will in a sec. Look up the Crab Nebula online. Go look at the Hubble images of it. Go look at, there's the Wyoming, the WIYN telescope.
Wyoming Infrared Observatory.
Yeah. It's bright enough that it's called M1 after Charles Messier, who was a French comet hunter. And he was always scanning the skies looking for comets, and he kept finding these same objects over and over again that were getting in his way, and he got pissed off enough that he made a list of them. And now that list is the list that you want to look at. It's all the big, bright, fuzzy objects in the sky, and this was the first one. And a couple of years ago, I went out with my binoculars in my backyard, and I could spot it. It's bright enough to be seen with binoculars if you have good dark skies.
Okay, I tried to take it out of binning to get a little more resolution, and I'm not getting a lot of light, so I kicked it back into a 3x3 bin. I wanted to get you a little more detail, but that's not going to happen.
So when he says binning, what that means is it's like you have all the different pixels in your image, and normally each individual pixel gathers a certain amount of light from the sky. And how much light it gets depends on how much light we're receiving. So really bright objects, you can easily get enough light in each and every one of these pixels that the pixel goes, oh, light, and sends you a picture. With faint objects, you don't always get enough light for the pixel to go, oh, I should do something. So what you can do is mathematically take these two pixels, and in fact this one up here. So you have 4 pixels. You chunk them together, and all of the light from all of those 4 different pixels suddenly becomes 1 pixel. When this happens, all of the extra light comes in, and you can suddenly see faint things much clearer, but you lose all of the resolution. So there's trade-offs. You can see faint things, you lose the resolution on the faint things. But for a lot of science, being able to at least see it is half the battle.
Well, I think that David has got Saturn happening, so why don't we go there?
Way cool.
Oh, wow. Look at that. So I see the questions are starting to pile up in the chat, and so let me sort of go through the standard stuff that we always go to. If you want to see this in full screen, you have 2 choices. One is someone will have already posted a link that is the sort of raw video stream, and if you click that, it'll pop it open into a window, and then you can full screen it and press F11 and you can full screen it. You can also watch it. Can you get full screen at the CosmoQuest, Pamela, or is it still in Windows?
No, because okay. I have all of the comments streaming.
Yeah, so you can also put in, you can install the Better Hangouts on Air extension, and if you have that installed, then I just can't look at the screen right now because it's too distracting.
There's too many awesomeness.
This is too awesome. So if you if you have the Better Hangouts on Air extension installed, then you'll get a bunch of little links underneath your window, and one of them is that you can maximize the screen, and then you can again press F11 and just take it full screen. So. Now, I know Stuart is trying to join us, but we're actually kind of full right now. So, so Stuart, I'm sure somebody, if a slot opens up, we'll let you know.
We have Jupiter, Saturn, the Moon, the Crab Nebula. This is amazingly full of wind. Yeah,
this is awesome. There we go. Oh, John just dropped out. I think he might have thrown himself on the sword for you, Stuart. So. If you want to join us.
The shot of Saturn's pretty cool. If you look just to the right of the planet, on the upper right, you can see that the ring doesn't quite meet the planet. That's because the shadow of Saturn is on the rings itself. And I'm trying to convince myself that I'm seeing the shadow of the rings on the disk of the planet just above where the rings are going in front of the disk, but it's hard to say.
I agree with you.
All right.
Whatever that's worth.
There are a bunch of questions. Okay, hold on.
That's pretty.
Yeah. So right now we have.
I can see the shadow of the ring on the disk from here.
Yeah. So we have We have 4 telescopes streaming into this hangout right now.
Yeah, Jupiter's interesting too.
All right, well, now I don't think we've seen Jupiter yet, so why don't we switch to Jupiter? And there's Stuart.
Hi.
Aha.
There we go. Okay, so this is Roy's view of Jupiter, and Roy's got just wonderful tracking, and this is one of the great things with his system, his setup. Do you want to try and queue up M42, Gary, while we're talking?
I can do that.
Awesome, thank you. This is so cool.
So he's got Jupiter centered, and you can see some of the bands going across it, those cloud patterns. If you look over to the left and below it, just follow those stripes off the planet to the left, you'll see 2 faint dots. And they're hard to see. They're almost at the edge. Those are actually moons of Jupiter. It's I think it's Europa on top and Ganymede on bottom, according to the map I've got here.
Oh, there we go. So, yeah, so when he changes the brightness, you can actually see the moons a lot easier. Yeah.
And the one to the right is Io, the volcanic moon. And Callisto would be farther over to the right, but you can't see it. It's off the screen.
No, we do see one off to the right.
Yeah, that's Io.
Okay.
Halfway between Jupiter and the edge.
So the reason that you see the 2 that appear to be on top of each other isn't that they're actually on top of each other. All of the planets form a plane, but the plane that we're seeing is tilted sort of like this. So you can imagine one of the moons is on the back side and it appears at the top, and the other moon is on the front side and it appears at the bottom. So they appear to be up and down from one another, and this is very hard to do with lag. They appear to be up and down from one another in the plane of the moons.
My mistake. This picture is flipped up and down from my map. So the 2 on the left, there's a brighter one on top. That's Ganymede, and the smaller one's Europa. I was looking at them thinking, wait a minute, Europa can't be brighter than Ganymede.
So is it Ganymede that's about the same size, if not bigger than Mercury? I never quite remember that one.
Yeah, Ganymede's the biggest moon in the solar system. It's bigger than Titan, and they're both bigger than Mercury.
Yeah.
I'll go ahead and zoom out all the way and brighten it up and see if I can see any of the other moons.
Yeah, I got that right. It's funny, these telescopes, the telescopes can flip left and right, they can flip up and down, it depends on how they're set up. And so it's not always easy to know what you're seeing.
Oh,
there it is.
Another one up there.
There's the 4th one. Okay, you've got all 4 in the view now.
And be careful, that it's the thing all the way in the upper right is Callisto. Just to the left of it and below it is probably a bright spot on the detector. That's not real. You can tell because everything's moving except for that.
Yeah.
Yeah.
Phenomenal.
That's lovely. Very nice.
And now let's go back to Gary. Oh, let's take a look at what Cory's got right now. Cory's got a view of the moon as well, and like I said, Cory is heroically guiding this by hand.
Ooh.
So, and I think he's got some wind happening as well, but it's quite a beautiful view of the moon. Phenomenal. All right, now let's go to Gary. So Gary is showing us the Great Nebula in Orion. Did you guys see him do the Horsehead Nebula the other night?
No.
I saw the still.
Yeah, let's do after this, Gary. I don't know if you can try and pull up the Horsehead Nebula. He can see the Horsehead Nebula.
It was a breathtaking view.
That's really nice.
Unbelievable.
Wow, that is fantastic.
How come we're getting the streaks on those stars over on the left-hand side?
They're bloomed.
Yes, and it only does it when I'm binning. I've never had it when I'm unbinned. That's kind of strange.
No, that makes sense. What's happening is, as Pamela was saying earlier, this is an electronic detector, so it's like buckets collecting rain, and they're collecting photons. They're collecting particles of light, and if something is too bright, that pixel will overflow and flow into the ones around it. When you're binning, you're actually taking, say, 2 by 2 binning, you're actually taking 4 pixels and adding them all together and putting them into one. And if you do that, you're getting 4 times as much light per pixel. So the brighter stars will definitely do that. And you get sort of this either a horizontal or a vertical streak, depending on which way your detector's pointing.
Yeah,
Oh.
it has an anti-blooming, but I guess that only works when I'm not binned.
There's only so much I can handle too.
Yeah.
Now, can you shorten the exposure time, because it's almost blowing out the?
Yeah, I stretched it a whole bunch, but yeah, let me take it down to 10 seconds.
Yeah, if those are bloomed, then that one bright star in the center is going to be blown out.
Yeah. So again, anyone who's watching this, if you want to maximize and see this in full screen, further up in the post, there's a big long. Bob Daniel posted this. It's a great big long video link. It says video.google.com, and it's a great big link. And if anyone from Google is watching this is like the first question we get every time, 100 times. You know, can you make a way that people can see this full screen? That's all they want. That's all anyone can talk about is full screen, please. So, so that's the one way is you can click on that link. It's about halfway up the page. The other way is you can install the Better Hangouts on Air extension, and then that gives you a whole bunch of buttons. Yes, Stuart, Guy, I'm talking to you. That's how you do it. All right.
And I will try and figure out how to write the software so that there's a make it full screen button on CosmoQuest.
That would be awesome.
I have a weekend plan now.
Oh, good, good. And the other thing we're going to do is create like an email announcement list, because we do this fairly randomly, but we're getting better and better sort of technology, and everyone's getting a lot more settled down, so it's working out really well.
And if you follow at CosmoQuest on Twitter, it will always link when we're doing this stuff.
Yeah, and we announce it on Universe Today, and Phil announces it on his, and so we'll try to get the word out. Because this is phenomenal. I mean, again, it's weird because, the first few times that we did this was all very shaky and we weren't getting, but now we've just got these beautiful telescope views. Everyone's view is rock solid. It's astonishing. So Roy's got, I think that's Mars, right? No, it's Saturn as well. You got Saturn up there. Oh, fantastic.
And it's flipped the other way.
This is actually stuff that I was recording the other night.
Okay.
Oh, so this is fake.
Yeah, it's fake, yeah. I just wanted to see if it came through and see if you could see the shadows on this one. This is what I had the night before last. It was directly overhead.
Early in the morning, though.
Yeah.
No, I'm getting an echo from somebody again. Great. Okay. Well then, and so like I said, do you want to try and go after the Horsehead Nebula, Gary?
Okay. Yeah, I've this is a 5-second exposure, but I still can't distinguish. I'd have to go to non-binning to distinguish the stars in the center. Okay, I will move it over to Horsehead.
That'd be great.
On the Google Plus post where this is embedded on Google Plus, where the Hangout is, I just put up a link to something I've written about the Orion Nebula some time ago that has a lot of information about it, if anybody's interested.
If anyone wants us to stop and like go on more about this, I'm sorry, it's gotten so easy that we're going really fast. That the first few nights of this was, we spent the whole night just looking at a couple of objects, and that was the best we could do. And now we're at the point now where we can switch to multiple telescopes. We've got different views. It's phenomenal. This is just
and
amazing.
my webcam is now.
Oh, great! Yeah, let's
active.
check it out. So here's Gary's setup.
And be pretty short. Oh shoot!
It's a short trip. Yeah.
Yeah.
Pamela, what was that Twitter feed?
Okay.
It's at CosmoQuest X, CosmoQuestX. And the reason for the X is X marks the spot, and somebody else already had it without the X.
Twitter squatters.
Yes.
Twitter squatters.
That's exactly what it is, actually.
And then Roy's got Jupiter again. Do you want to go back to the moon, Roy?
Don't we all?
Yeah.
Where's Elon Musk?
Okay, I'll go back to them.
Okay.
All right, there it is. See it?
Oh, wow.
Oh, we got an echo on you, Roy.
Oh. Hey,
That's
look at that.
a 10-second, and I'm bin 3x3.
What filter?
Excuse me?
Are you using a filter?
Yeah, hydrogen alpha. It's the only way I can see anything through all the city lights here.
Sure.
So does anyone want to explain this? Explain this!
So what it means to say that it's a hydrogen alpha filter is the way his system's set up, we're only seeing light from the specific transition in the hydrogen atom that emits the same red that you see in open signs at pizzerias and stuff. And the reason that you filter on that particular color is streetlights don't use it, so you're able to get rid of a lot of sky glow. And all of this light is coming from, I believe, nearby young stars, and it's passing through a gaseous nebula. And as the light passes through the nebula, the blue light gets scattered in all different directions, and it leaves us with the beautiful red. Now, the reason the Horsehead is there is there's actually a pocket, a column of very dense material. And that column of dense material, sort of like the pillars of creation or other columns of dense material, it just happens to be shaped like, well, an Arabian horse.
Okay, that's.
Yeah, I always thought it looks like a chess piece.
It absolutely looks like a horse, though.
Yeah.
Well, yeah,
That is amazing.
Yeah, night. You've got glowing gas on one side and very much denser dust between us and it, and that's why you're seeing that silhouette, and you can trace it, that ridge going all the way across. You can even see, yeah, there you go, to the right is a brighter clump of gas being blocked by even darker dust. That's the flame nebula, I think, is the colloquial term, isn't it?
Yes.
Because it looks like a candle flame.
The window I'm actually sending is smaller than I've lined on the screen, so I'll have to remember to make that bigger in the future.
And that would be Sigma Orionis.
The star there.
Yeah. And so if you look at Orion, and of course Orion is marked by the 3 stars in his belt, and just from the northern hemisphere at least, on the left-hand star, just down below it, just below it, is another star. If you're in the southern hemisphere, that would be flipped. And I believe that's the star we're seeing here.
I thought it was the left-hand star in the belt, but I could be very wrong.
I'm going to say that and then I'll be wrong.
Yeah, I think the left-hand star in the belt would blow out your detector.
Maybe.
This is a notoriously difficult thing to image because it's tiny. And there's not a whole lot of light there. The only time I've ever imaged it, I have to admit, I was squatting on a 107-inch telescope.
You know what? I think he's right. No, that's my mistake. That's Alnitak. That is the 3rd star in Orion's belt. Sigma Orionis is, okay, I got it now. Sigma Orionis would be above the Horsehead Nebula, just off the field. But that's what's actually lighting up this nebula.
But I know that, the view we've seen from Gary's telescope before, the field of view is so wide. This nebula is actually really big, isn't it?
Yeah. I can actually tell you because I've got a nice little thing of it here.
The Horsehead itself is only a couple minutes across, so it's fairly tiny.
Well, but I'm just thinking of the times that we've seen like Jupiter and such on Gary's screen.
No, that's
like
true.
it's about as big as Jupiter, right?
One of the things that gets squirrely about talking about large and small is with nebula, you end up with things like the Great North American Nebula that are degrees and degrees and degrees across, and you need these huge detectors to be able to see them. And then you have things like the Owl Nebula, the Horsehead Nebula, that are small, similar in size to the moon on the sky. Similar to the size of the large craters on the moon on the sky. And so when you start talking large and small, it's such a different scale than when you're talking about planets being large and small in the sky.
Yeah, the planets on mine look like some of the stars in this picture. I don't get them all.
The field of view here is maybe a degree.
Yeah, I'm 87 arc minutes by 65 arc minutes.
Right.
What really impresses me is your dynamic range, because I would have assumed that a star of Orion, as I said earlier, would have blown out your detector. But you're getting it with haloing, but not a lot of haloing. And the fact that you don't have ginormous spiky bits coming off of it says a lot for your chip. That's a really good detector.
I'm very happy with the camera. It's done a great job.
And we're talking tech geek stuff here, but for those of you who aren't quite as familiar with all that, the full moon in this picture would you'd just be able to fit 3 of them across. So the Flame Nebula there on the right, that gorgeous gaseous blob, is somewhat smaller than the moon would appear in the sky.
Yeah.
But it's very, very faint. I've never seen any of this through a telescope.
No, neither have I. This is a phenomenal view of the of the sky.
And seeing all sorts of ridges, it's just beautiful.
Well, we've gone through our whole agenda for the night.
Eris. Does anyone have Eris? It's at opposition tonight. So the reason that I keep bringing up Eris is this is one of the larger and earlier discovered asteroids, and it was used in the early 1900s to set the scale of our solar system. And after the measurements made in 1931, we didn't have a better way of determining the size of our solar system until radar was capable of being able to be used usefully in the late 60s. So right now there's a lot of people scattered all around the planet who are in the process of trying to recreate those historic observations that were made in the 30s and to do it with photo documentation so that their images can be used by school kids to figure out how is it that people actually could make all of these measurements using Kepler's laws, and the fact that if you put an asteroid in front of the stars and go from southern part of the planet to northern part of the planet, you can see the asteroid move in front of the stars. It's really cool. So I don't know if anyone has Eris up. It's high in the sky at midnight right now, and I don't think it's near midnight really anywhere right now that we have, unless you're in the middle of the Atlantic on a boat.
Next clear night, I'm going to take it.
Yeah.
Next clear night, I'm going to take a stab at it. Hopefully, I'll get some success. I was off by a little bit in my my understanding of how time zones work last time.
I'll add that. Oh, go ahead.
I was just going to say the awesome thing is opposition means up at midnight.
Fraser, can I make one point?
He seems to have left the building, so go ahead.
Okay. You don't have to have a really nice, expensive camera like this. To do astrophotography, I use just my DSLR, and you can get some pretty decent views with the DSLR. Certainly not this crisp, but it's not imperative that you spend $5,000-6,000 or even more on a good CCD camera. I just spent $500 on a DSLR body, and that's what I use.
Yeah, I got hooked. I just hooked, line, and sinker. I put together a PowerPoint presentation for my club, and it was my journey and why it might have been smarter and cheaper to get on drugs. I'm going to slew it over to M52. How's that sound?
Sounds good.
M52?
Yeah, and I'll put. I'll let you watch the scope while it's going.
I'll add, Pamela was talking about, how are you pronouncing it, Pamela?
How was I pronouncing what?
Eros?
Eros, it's like the Greek god? E-R-O-S?
A friend of mine who studies asteroids says it's actually Eros. And it's like, well, and I said, yeah, but nobody's going to call it that. Everybody calls it Eros or Eros.
Yeah.
Or everybody pronounces it differently. It's E-R-O-S. And it's up until recently, it was the only asteroid that was actually orbited by a space probe. And the Near-Earth Asteroid Rendezvous, or NEAR, N-E-A-R, which was later renamed NEAR Shoemaker, orbited Eros for a year and just mapped it and mapped it and mapped it. And if you look up those pictures online, they are so cool. It's like a bent potato, like halfway between a potato and a banana. And the close-up pictures of it are just out of control. It's so cool. And they actually landed the probe on, as the end of the mission, they tried to land the probe on the asteroid, and they got closer and closer, and then lost. I think they lost communication right as it bumped into the surface, which they kind of expected. You don't quote me on that, but if you look it up, you'll find all that information. And as I recall, it went into orbit around the asteroid on Valentine's Day, whatever year that was, like a long time ago, 10 years ago or something. And that's funny because Eros was the god of physical love.
Yeah.
I'll put it that way. And so it's funny that they did it on Valentine's Day.
There's some typing coming from someone.
Oh, that's me.
Oh, is
Sorry.
that you? All right.
I'm a bad human.
And then I hear some echoing, too. I know I'm on total echo patrol tonight.
Ooh, what's this?
M
Is that M52?
Yeah.
That is an open cluster.
Yeah, but
there's
what's down there at the
also-
bottom? I
that's
recognize that.
That's the bubble.
Yes. Okay.
Let me
Yeah, there you go. Oh, cool.
squeeze it a little bit.
You got a straight line going across that image.
That's probably a satellite. The airplanes are usually a little brighter.
Yeah, we had an airplane go through last time.
Yeah, so this cluster up here is the M52. I knew there was something near M52, but I couldn't remember what it was.
That's a gorgeous shot. I mean, that's a gas cloud where stars are forming, and then the high mass stars, very hot, and they blow off a tremendous wind of gas, like a solar wind, but much stronger. And as that stuff expands, it basically carves a cavity in the middle of the nebula. And this one happens to be fairly round, and I mean you can see it. It's like a soap bubble. The Orion Nebula is similar, but it's so big it's hard to see it. It's much more chaotic. This one is a beautiful example of that. So if you look up the soap bubble nebula again, you'll find a million pictures of it.
And Rob has a question.
That's awesome.
How does one of the high-end CCD astrochams make better photos in high-res DSLR? One of the biggest things is it's cooled to get rid of noise. Right now I'm running at minus 20 degrees C, and that reduces the noise in the chip significantly.
Now, is that 20 degrees below ambient temperature then?
I miss that.
Oh, is that 20 degrees below ambient, the air temperature that you're running it at?
I'm right now
With the cooling? No?
40 degrees below ambient. I'm showing my
Okay.
ambient as
Thank
plus 20.
Gotcha.
And it's doing minus 20 cooling. Anybody have any requests?
Yes, everything. Start at NGC 1.
Well, that's the plan. So my to show a demonstration of our awesome power, the plan is to do a Messier marathon in like an hour. We'll just get we'll get like 8 telescopes rolling. We'll just in different parts of the world, and we'll just run through the whole Messier catalog in like an hour. That's the plan.
Yeah, you can only do that at one time of the year, though.
Yeah, well, whatever that time of the year is, we'll get telescopes on
is that
different parts of
March?
the
Is that when the Messier marathons are done?
Yeah, it's in
year.
March.
I think so.
Yeah.
So Charles Messier, again, he observed all these objects in the sky over the course of several years. And they're scattered north to south, east to west. And it turns out that for a short time in the year, right at sunset to sunrise, you can go to each object. And there's 100 and... Well, there's some arguments about that. There are 109, right? But some of them aren't official.
Some of them got lost and renumbered.
Yeah, like two of
Whoa.
them were the same object. I mean, there was or one of them was a double star. All kinds of crazy stuff like that. But you can't observe them all in one night. But you have to. I mean, as soon as it's dark enough, you have to spot it and then move on to the next thing. And then there's like a lag of several minutes between two of them while you're waiting for them to rise, and you can look at other stuff. But it's supposed to be pretty grueling. I've never done it.
I've attempted it and not succeeded, but I did attempt.
Now, if anyone noticed, Peter Lake has has joined us. He's actually in Australia, but he's got his telescope pointed at. He's got an automated telescope running out of the U.S., I think. So I'm not sure. I don't see a view in his screen, so I'm not sure if he's actually looking at anything.
His is in
Oh,
New Mexico.
look at Roy's shot of the moon there.
Yeah. You want to see Roy's moon again?
So it's red because of all the rose quartz, right? I'm kidding.
And I'm going to slew over to M81, M82 here, so
Oh, sure. Yeah.
whoever wants to see the scope slewing.
People have to make some requests now. We've gone completely through my agenda, and now we're in open territory now. Do you want to look at the moon? Should we look at Saturn? We can do whatever you want.
And I see a request for M79, so I wrote that down.
Okay.
Okay, we've settled down.
The reason that the moon is the color that it is because of the I'm using a DSLR for the shot, and I can set the different white balance is all. So I can go through different white balances for this, and I don't have a white balance set specifically for this live view.
So can you try zooming in on that area up at the top of the moon? Sort of where it's all cratery up at the top there? Yeah, up there.
Right up in there.
Yeah. Oh!
Sweet.
Let's see if I can focus it a little better. Temperature's changing here, so it's getting out of focus some.
Imagine what it was like for poor Galileo, whose view was nowhere near this good, to go from thinking he was going to be looking at something that looked like a painted glass ball, which they had plenty of in Italy, to instead realizing, wow, that is not a perfectly smooth surface that's essentially been painted.
Hi, John.
Hi, everybody.
How's your seeing tonight?
My seeing is completely clouded out, unfortunately. I had some good opportunity last night. I enjoyed some visual observing myself, but I'm certainly enjoying the hangout here and the spectacular views that are coming up there. Looking forward to the M79. I put the request in for the Globular Cluster.
Oh, good. Okay, yeah. So, and I think we can see there it is. Yeah, you can see the spiral. So, Gary, you've got, what is it, M81 there?
Yeah, M81 and M82.
Oh, that's nice. Yeah.
So I don't know if everyone can see. So you can see the spiral structure of the galaxy there.
And that's at a 30-second exposure.
Wow.
Now, one of those is face on and one of those is edge on, right? Is M82 the edge on?
I was afraid somebody's going to ask that.
That's correct. The one on the left is M81. It's mostly face-on spiral. The one on the right is M82. It's smaller, and it's
Pamela's
edge on.
holding
It's
up
also
a prop here. I don't know if you can see. She's got a prop for the different views.
It's prop night on the Hangout, right?
So there's M81. You might be muted, Pamela.
I think she is, yeah.
Yeah.
Okay, no longer muted. So this would be face on. This is not what we have. What we actually have is tilted more like this, and then to get the edge on, it's tilted like that.
Do you mean face on like this, Pamela?
Yeah.
There we go.
This is my one really good prop I'm proud of. I made this. It's not like Emily's spacecraft, which are phenomenal, though.
Okay.
And M82 is a mess. It looks funny even in this picture. You can see, it doesn't look like a nice smooth edge-on galaxy because it's loaded with dust. It's a starburst galaxy, lots of stars being born, and they blow off huge amounts of dust. And when you look at detailed images of that, it's complete chaos in there.
Yeah, there's a huge band going across it. Really gorgeous and a high res.
Yeah, when you look at it in infrared, you can really see that. It's all this dust that's being blown out of the galaxy by the combined winds of all of these stars. And when you see it, when you look at these pictures, you look up M82 and you'll find pictures of it, deep Hubble and Spitzer and all these other telescopes. And it's just, you can see it. It's like this thing is blowing out material. It's amazing.
Okay, how about I'll swing to M79 now.
All right.
So while he
That'd be
does
awesome.
that, I'm going to
So I don't, Peter, can you?
all
right. Well, we'll see you.
I'm going to let you know that next clear night I get, I'm going to go after, I believe it's pronounced Eros. Now that I'm educated. Thank you, Phil. But for me, it'll be out like 12 or 1 East Coast time, so I don't know if that's too late for you, Fraser, or not.
Oh, not for me, but it's only. In fact, it's like it's almost that time now, isn't it?
It's
no, I guess it's 11. Yeah, no, that's totally fine. That's better. Later is better.
To clear the trees, but it'll be a couple days. But it's definitely on my to-do list. So.
Okay, yeah, that'd be great.
And don't forget to report your data.
Report your data. We need to figure out how big the solar system is.
Yeah, someone will have to teach me that one then.
All
right. Good night, all.
Good night.
Good night.
Night.
Oh, is that the globular cluster there?
Yeah, it's a pretty small one. Let me give it a little more exposure. That was 1 second.
That's funny. I don't remember it being that faint. This is one I used to look at when I was a kid in the winter. But it was always really low. This is
it is pretty low.
And so the more we do of this, the more we do this, the more people will start to learn the night sky, I'm hoping. And, there's the best globular cluster is the one that you see in the summertime, which is the great globular cluster in Hercules. What's M13? Yeah.
Yeah, there's a handful. There's one in Pegasus and one in Bodes that's really nice, too. Oh, there you go. So this is in Lepus the Rabbit, which is this not a very distinguished group of stars, a constellation underneath Orion's feet. All the constellations around Orion are sort of related to him in one way or another. He's hunting along a river. He's fighting Taurus the bull. He's got a rabbit hanging down that he's already gotten.
Oh, yeah, this is cool.
It's low for me, and it's also looking in my worst direction. I'm looking at my biggest light bubble that direction.
This is kind of great. It's a view of this is actually Roy's setup. So he's actually built this observatory in the middle of the Arizona desert. You can see he's got his solar panels there, and he's got sort of a shack, and then in the back of that shack is where he does the observing.
It's like a Ghost Hunters video.
Yeah. Yeah, totally. Does anyone see a ghost? Did you hear that? Did you hear that? Oh, there we go. That's a really good view. That's perfect. Go back to the one you had there before, Gary.
Okay.
Hey, look, M79 is also a grenade launcher. Huh.
There you go.
Yeah.
And for those of you who are on the CosmoQuest Hangout and couldn't figure out why the Google Plus comments stopped, I fixed it. It's because for the first time ever we got more than 50 comments, and my software went, no, I can't handle that. So thank you for breaking my code in really awesome ways, and it's fixed now.
Well, we're up to 214 comments now, so. We've got a couple of requests for M51.
I think that's where I just was, but I'll go there.
That's got to be low.
I went to M52, didn't I? Let me make sure it's in my field of view.
M51 is the Whirlpool Galaxy, and it is in the constellation Canis Venatici.
Yeah, Venatici is how I've heard it pronounced, but I don't know.
I'm not showing it.
It's pretty low. It's off the tip of the handle of the Big Dipper.
Oh yeah, it's going to be way up north for me.
Yeah.
And it's funny. This is a face-on spiral. It's relatively close by, and I was never able to find it with my telescope when I was a kid. I had a 10-inch Newtonian, big old light bucket size of a water heater, but it's faint. The light's spread out. It was always a pain to see.
I could never find it either.
I finally found it when I was in really, really dark skies in Virginia with a pair of gigantic binoculars. And I mean Navy binoculars with 4-inch lenses. They were awesome.
Oh, look at this. So I've gone to Roy's view of the moon, and look at that crater there, and you can see like a teeny tiny little crater inside it.
That's a mountain. Oh, that's a flat. That's a walled plain. I wonder which one that is. Do you have a map, Pamela?
Let me pull it back up.
I had one, but it wasn't terribly useful.
Sort of right on the terminator. It's a pretty big crater, though. There you go.
Okay, thanks. That's what I needed. So, Oh, it moved too quickly, and
Look,
I
that
need to
perfectly
put my
formed
other.
Can you back out? Can you zoom back out again, Roy? Yeah, and then maybe go up a little bit with your little box.
I'll need to find a good interactive moon map if we're going to keep doing this.
Yeah, I found one at lunarrepublic.com/atlas.
Lunar Republic.
Yeah.
Isn't that...
They may be
of course.
crazies, but they made a perfectly good map.
Okay, yeah, these are the guys who claim they can sell property on the moon.
Right, so you can...
It turns out, no, they can't. That's illegal.
Yeah, so they may be illegal, but they make perfectly good maps. Oh man, so the reason that you're seeing me do this is because the map I'm looking at is flipped and tilted sideways, and my three-dimensional reasoning is good, but sometimes requires contortions.
Roy, what software are you using with your camera?
See if I can pull it up on my...
Oh, people in the comments are making fun of my accent. A boot. There, you happy? A boot? A boot?
Unfortunately, M51, I'm looking at the side of my observatory right now.
Oh.
Yeah, it's not surprising.
Let's see.
Yeah, M51's pretty cool. That was the galaxy that just had a, not too long ago, a couple months ago, a supernova, I believe.
Yeah.
Yeah, that's the whirlpool, and I actually got a shot of that with that going off. It's pretty neat. Let's see, we've got some other stuff up here. M108.
Oh, I know which crater that is. That's that one.
That's a galaxy.
Did you finally
Looks
find
like
it,
it's like
Phil?
Theopolis.
It's Ptolemaeus.
Ptolemaeus, okay, that's how you pronounce it.
Or Ptolemaeus, as Carl Sagan would have said.
It's like
Ptolemaeus.
Theopolis or something.
Cool. Yeah, that's a big old crater that's filled with lava after it formed. So it's a flat-floored crater. Let's see if I can find a better map of it.
And you see Peter's got his telescope pointed at Phil Plait.
Uh-oh. That's bad. Oh, look at that. Man, I am a dorky-looking guy.
Aha! I found it on the map I'm looking at, which has absolutely nothing labeled, but I'm happy that I found it. So one of those has a mountain. The one on the left top has a mountain. The one lower right has a crater. And I'm not sure if it's so much a mountain as a splashback from when it formed, because what you get with a lot of craters is as they form, all of the material essentially gets liquefied from the energy of the impact. This is why most craters are round, is it's actually the energy of the impact causing all of the material that absorbs that energy to start acting like a fluid. And it can splash up and then splash up in the center and solidify before it has a chance to form this completely flat bottom.
Well, I'm sure
This is a perfect example of relative dating of a crater. You can see Ptolemaeus as the big flat crater there, and there's a little tiny crater inside of it. That's what Fraser was mentioning. That must have been from an impact long after Ptolemaeus formed,
Or
else
at
it
some
would have
point
gotten washed
after.
over.
That's one of the frustrating things is you can't actually tell long or short after. It could have just been long enough that the material in Ptolemaeus solidified, or it could have happened 3 days ago. Well, we would have known if it was 3 days ago, but still.
Yeah, that's a big crater. Actually, I wonder how big is Ptolemaeus? And I misspelled it. It's an ancient lunar impact crater close to the center of the near side. It's joined by the crater Alphonsus, which is...
I'm using Virtual Moon Atlas, and it looks like it's 158 kilometers.
That's roughly what I've got, yeah. That's big.
Yeah.
That's 90 miles, or 100 miles across.
One of the things that's amazing about the moon is if you ask a lunar scientist how many craters are there that are roughly 100 meters or so across, it could be a number as high as 500 million. So 500 million craters that are a distance you could probably walk without hating yourself.
If you could hold your breath.
Well, yeah, there's that.
Okay,
Is there any
I've
specific feature on the moon you'd like to see?
See if we can see the straight wall, which should be above those craters.
Or below, as the case may be.
Or, yes.
That whole
Making
flippity
Stargate
flippity
references
bit.
in the room. There you go. There's the Apennines.
great vacation spot.
That's pretty.
I love how if you let your brain's imagination take over right now, you can almost imagine this as a fossil fish with a giant eye socket and snout. No one else is with me on this one. Sorry,
I see a mountain range.
Spinal ridge, and then the fins, and then this round eye socket.
It's actually the edge of an enormous impact basin.
Yeah.
That's, you know, hundreds and hundreds and hundreds of kilometers across, and most of it is eroded away after multiple impacts. But that, you know, that used to be the rim of basically an enormous impact crater. You can see that it's curved.
And the reason that it's flat on one side with the fall off on the other is that's actually the ejecta blanket, the material that got splashed and splattered around during the process of the impact.
I don't know, Peter, can you hear me? You've got a view in your telescope right now. Nope,
You know,
nope.
the mountains you're talking about, aren't we looking at Tatooine? Isn't that the skeleton on the sand dune?
See, that's what I see. That's totally what I see.
Many Banthans died to bring us this image.
So there appears to be a
Sorry,
pretty
guys,
edge-on spiral over with Gary. What is that, Gary?
That is M108.
Ah.
Now, I got something else in this picture that's kind of neat. Let's see.
Aha!
Oh, ow.
The Owl Nebula.
The Owl Nebula.
Nice.
Okay,
Can you
so I
just
have-
zoom over? Can you just zoom over to that, Gary?
This is so cool. This is, again, one of those things that I looked at with a 107-inch telescope, and you're doing an awesome job with something way smaller.
And that is actually a 1-minute exposure at the galaxy.
Dang. So the Owl Nebula is a planetary nebula. This is something our sun could actually form someday in the future. All planetary nebulas have different weird geometries, we think, depending on what's orbiting the star that puffs off its atmosphere to form them. And this is just a beautifully symmetric one that appears to have two darker regions that look like owl's eyes at low resolution.
Can you just refocus on that object, Gary? Just get that in the middle of your field of view?
Yeah. Hang on a second.
These funny shaped nebulae like this. There you
Oh.
go. It looks weird, but it's actually kind of a short barrel, like a soup can with open ends. But if you imagine a soup can is sort of transparent, that's what you're seeing. The two circles are actually the open ends, and the ridge in between them, the bright spot, is just a perspective effect, like you're seeing a paper towel tube almost on end like this. And it's not that long, but you can imagine. And that's all that stuff, all the dynamics of how that works out, the physics of it, was being worked out around the time I was studying them back in like 1990.
Yeah, this is fairly recent science.
Yeah, they're complicated, it turns out. They're really hard to understand why they're shaped the way they are.
Okay, I'm jogging it over there.
All right. Now, we've got a couple of questions I thought I would answer. One is, where was it here? So Steve Fines wanted to know, why isn't such a large impact crater any deeper?
Oh,
Filled up.
yeah. What he said.
Uh-oh. Warp drive.
Yep, there's what happens when you take an exposure while it's moving.
All right, we'll go look at the moon. Calmly look at the moon.
Yeah. When you have a giant impact, a really big one, it basically liquefies all the rock, and then that rock just fills up the impact. So you can imagine, one way to think about it is if you have thin ice covering a pond and you punch it, you don't get a crater, you get you get water in it. Sometimes these craters form over a region where the crust is thin. Not so much anymore. The moon's crust is very thick. So that would have happened a long time ago. But once the moon solidified, basically the energies of the impact are beyond imagining. I mean, you're talking about creating a crater that's hundreds of miles across. So the energies involved are thousands and thousands and thousands, maybe millions of times all the energy of all of our nuclear weapons combined. So it's big.
Yeah. Oh, look at that one. You can see the central peak. Look at that. Up at the top there. I'm pointing at my screen, but I guess that's not really any value to anybody. Up at the top of the screen right now, you can see a central peak in the middle of that crater. You actually see a couple of them. Yeah, I see 3.
Yeah, the one at the bottom is such a beautifully well-defined, simple crater. Nice sharp rim.
Yeah.
The one at the top looks like it has terracing. It looks like the rim slumped a little bit, and you get multiple rings. Well, not multiple rings. That's the wrong term. I'm sure some lunar geologist would yell at me. On big impacts, you actually do get rings surrounding the crater. That's the one at the top that has the central peak and the little tiny crater inside of it. The rim probably collapsed, and so you get what's called a terrace.
Wow. All right, let's see what Gary's got now. Okay, there's the L Nebula. I guess you're starting to memorize all of the settings, Gary. What's the right way to display each one? Oh, I can see a little bit of reality leaking in over on the left-hand side there.
Sorry about that. I had myself muted, so you didn't hear any of the clever comments I made.
No. What was your clever comment?
Something about memorizing what the stuff is. My memory doesn't remember that far.
I believe I said it 4 seconds ago.
Yeah.
Yeah. Yeah, that's beautiful.
There's about this contrast.
So I wonder how big that is. That would appear about as large as Jupiter in the sky, wouldn't it? Even a little bigger.
Oh, that's bigger than Jupiter appears in my scope, yes. Yeah,
all planetary nebulae are roughly the same size. I mean, the biggest ones are a few light years across. Most of them are 1 to 2.
Oh, we suddenly got very meta with Phil. It's a Mobius Phil.
Yeah.
Oh, look.
Yeah, well, this is Peter pointing his telescope at Phil again.
I've been accused of being one-sided.
The dark side of Phil just wouldn't make as good of a CD name.
That's cool. Oh, and we've lost David.
I'm back again now. Can you hear me now?
Yeah, we can hear you.
Okay, I'll just get the view back again.
Is there a way to zoom in and not have the extra window stuff? This is that computer reality that we don't like to view. We like to just see telescope. So which one's Eros?
It's that one.
Can you hear me, Fraser?
Yeah, I can hear you.
Yeah, so, hi. Sorry about it. So have you just got the photo now?
Mm-hmm, yeah.
Should have just the screen. So Eros is the brightest one, I think, with the line, the diffraction spike coming from it. I haven't confirmed that yet because I need to run the astrometry over it, but it's either of those two bright ones there. So this is in Spain, taken about half an hour ago, where it was about 45 degrees above the horizon still, and it will be rising, as Pamela said earlier. Midnight's the best time to observe it because it's at opposition. And it should be rising probably in about an hour or so. It'll be in telescope range from New Mexico. So one of the great projects I think Pamela's got on her website there at the
CosmoQuest.
Planet Quest or
CosmoQuest.
CosmoQuest. See, I'm still learning the name.
It's all right.
CosmoQuest. And the beauty of this experiment, it's one of the traditional experiments that astronomers have done for a long time, observing it at opposition from two different places on Earth so you can measure the parallax of it. So part of the citizen science initiative that's on the Cosmic Quest website there is people can actually take photos of Eros with their CCD cameras or anything that supports a FITS format, which is a scientific header format for astrophotography, and upload it to the website and mark the coordinates. And they're doing a live citizen science project over the next couple of days to measure that parallax between different places on Earth, which is really quite exciting.
Very cool. Yeah, and I think that's what we mentioned Mike was going to try and do tomorrow night. So Gary, you've actually gotten the moon in your view.
Yeah, I took it down to 1/100th of a second, the gain all the way down, and it's no binning, and I can actually make it out.
This is the joke that we make. The problem with Gary's telescope is that it's so fast and gets such a wide field of view that it just is not really that useful for doing any narrow field stuff. And so to get, as he said, he's essentially had to turn off every piece of its, turn way down the amount of light that's getting in. He's had to, only view it for a fraction of a second. And now we can actually make out something on the view of the moon. That's amazing.
And I'll move it over to Jupiter here.
God, I could watch that all day too. That's so cool.
That'll be interesting to contrast Jupiter on mine and Jupiter on his.
Yeah, yeah, and so this is an interesting thing where the it's about the field of view. It's about the oh man, I'm getting a huge echo somewhere. It's like whack-a-mole to try and figure out who's producing the echo. Yeah, this is it's interesting because you've got all of these different pieces all coming into play. You've got the size of the telescope. You've got the quality of the seeing, but you've also got what eyepiece you've got connected to the telescope. If you've got a Barlow lens that's serving to multiply the view of the image, and all of these come into play. And so you're going to see different sizes of the object in screen, and you're going to see different resolution on the image as well. If we had Mike Phillips's telescope here, and even the one that Stuart had the other night, it's actually a much larger view, but it isn't necessarily a higher resolution telescope. It's all about the eyepieces. It's all about the how they've got it configured. You got Jupiter happening?
Yeah, that's my
There it is.
entire field of view you're seeing right now. With Jupiter. Now I'll zoom in a little bit.
So this is the hilarious irony, right? Which is that Jupiter in Gary's phenomenal telescope doesn't look a lot better than what you would see with a tiny 3-inch reflector. Like if you got a Celestron first scope, I think it would look better than this.
Yeah, that's at 100%. So you're seeing pixel per pixel, and there's a 400% magnification.
Can you turn on the brightness at all?
I'm about as low as I can go. Let's see.
Put your hand in front of the aperture.
Yeah.
Yeah. I'm trying to think
Yeah,
of any kind of analogy, with a race car or something.
I can almost see bands.
Yeah.
With telescopes like this, you actually have to go out and put a pizza box with a hole cut in it over the front of your telescope to reduce the light. It's a bit humiliating, but it works completely well.
Yeah.
Yeah, and it still doesn't give me the resolving, because I'm about 1.5 arc seconds per pixel on my camera, which is wonderful for deep sky stuff. It's not great for planets.
Yeah, and there's Roy's view. And so you can see, even though Roy has a much smaller telescope, he actually has a much higher resolution view of Jupiter.
Mm-hmm.
I guess it's not that much smaller. Yours is 14 and Roy's is 8-inch. So.
One of the amazing things that can sometimes come home to you with this whole problem of resolution versus aperture size. When I was an undergraduate, Shoemaker-Levy 9 decided to commit suicide on Jupiter. And they opened up the mountain for all the amateur astronomers to come up. And there were people with 10-inch, 14-inch telescopes who could see the pox marks on Jupiter from where the impact stirred up dark material from lower down in the atmosphere. And there was a whole group of us summer interns who were all doing support observing on the Schmidt telescope, which has this giant degree-sized field of view. And we were imaging the fragments as they were getting ready to plunge. And because we had such a large field of view, we couldn't actually resolve any of the pock marks on the surface.
Why don't we go back to M33, Gary? Go back to Andromeda, if you would, because that was sort of where we started.
I muted myself. I was.
Oh, that's where we started this evening, and so I thought, as we start to wrap things up, we can sort of make sure that anyone who joined us. And then the other thing, Roy, some people are asking to see the Galilean moons, and they're there right now. You just can't see it because of the way he's got the brightness set up. The problem with it is they're there. So he can change the brightness of the view of the telescope, and then you can see the moons. Callisto, you can't see; it's off to the side. So
I reset my exposure to 5 seconds, and you can see the moons.
There we go. Same thing. So you can actually see. Well, the two are kind of blurring over top of each other, but it's the brightness is blowing out the detector for Jupiter itself.
And that's one of the differences.
Hey, Gary.
Yes.
What altitude can you get? What's the lowest altitude you can get through your pod?
Oh.
Right now, Eros would be about 14 degrees, but the magnitude's like at 14.7, so I'm not going to be able to see it, but you might be able to on that fast scope.
14 degrees, where is it?
So to translate into English, the question is, how low can you point your telescope before you're looking at the wall?
I can give you right ascension and declination from here, but I have no idea of there.
Oh yeah.
He can probably just type it into his finder.
It's that one. That one is not going to know. I'd have to look that one up.
Well, the field of view is large enough that if you have the Orion deck from a different location, it'll still be valid. So the problem with this object is if you look at a galaxy, you look at the galaxy from anywhere on the surface of the planet, and it's going to appear at the exact same position on the sky. But if you start looking at something really nearby, like an asteroid that's 0.18 AU away, or about 70 times the distance to the moon away, it's close enough that depending on where you are on the planet, it's going to move slightly in the sky the same way if you hold your finger up and look at it with your left eye, it appears to be in a different place than if you look with your right eye. So these two telescopes are the equivalent of left eye and right eye looking at your finger. Luckily, the one field of view is big enough that it should be able to not get too offended by that difference.
If you give me your RAN declination, I'll point it there.
Isn't it just? It's just going to be a dot, isn't it?
Yes, but it's a meaningful dot.
A meaningful dot.
I typed it into chat. If you
did you do it in Google Plus?
Yeah, the right.
It's in the screen share.
I'm not seeing it. What am I missing?
I can just tell you what it is. The right ascension is 10 hours, 33 minutes, 39 seconds.
Mm-hmm.
So Charles, Charles Wagner, I hope that met your requirements to see the Galilean moons.
I just cut and pasted it into the chat, into Google Plus.
Okay, and what's the declination?
Declination is -6 degrees.
Okay.
17 minutes, 19 seconds.
Okay, let me see if I can get that.
At least that's what my iPad tells me.
Although we might end up getting the wall of Gary's observatory.
Very possible.
Yeah. Yeah, it says it's 14.7 degrees right now, so.
39.
to 14.17.
Okay, and it's minus.
Now, is that for you? Is that for your time zone, or is that for Gary?
Yeah, that's for here, but I think what Pamela was saying was it should be in the field of view.
Well, he's a time zone back from you, so he's probably going to have a lower,
That's true. It may still be a little bit lower
Yeah.
over on the further west coast.
See you later, John.
Actually, I am going brain dead here. I can't figure out how to enter minus in my Celestron keypad. 1033.
I can try it on my other telescope, but it would just take a longer exposure.
One of the things
Because
that's
it's in f6.
One of the things that's kind of frustrating about the asteroid being at opposition is normally you have an asteroid in your field of view because you take a couple minute long exposure, the stars are beautiful crisp dots, and the asteroid trails. Now, since Eris is at opposition, its motion relative to the Earth basically causes it to stand still in appearance relative to the stars. Now, if we were looking at Mars or something in opposition, it would appear to stand still and then temporarily reverse direction. Eris actually has a geometry that it doesn't appear to reverse direction. But we still have that standing still problem that prevents it from nicely trailing in short exposures.
It's going to look right at us, isn't it? We're going to stare right into our own. We're going to stare right into our own souls. Oh God, it's looking this way.
It is rather ominous.
Yeah.
Well, there you go. You can see the camera mounted there.
Where's the music from the box as or however you say that?
That's good.
This is pretty cool, actually. Normally, we've got to look down the throat of the telescope there. Normally, that's just a mirror, a little circle mirror. The light bounces into the telescope, hits the back where the main mirror is, bounces to the front of the telescope where there's a little mirror, a secondary mirror, and then it bounces back to the back end of the telescope and through a hole into the eyepiece. But what he's done is he's mounted his camera where that secondary mirror is. So there's one reflection. The light hits that main mirror and goes straight into the camera. And when you do that, you get a much wider field of view, and you can see much fainter objects.
Historically, with the really big telescopes, like the 82-inch at McDonald Observatory, the 6-meter in the Soviet Union, they'd stick a cage there and actually put a human being at the front of the telescope to keep the focus very carefully in focus and to guide the telescope by eye while hoping that you didn't freeze, pee, or fall.
That looks to me like the inside of his
that's the
observatory.
That's the edge of the pod. Can't quite do it.
Just out of curiosity, Pamela, have you heard stories about people in the Cassegrain cage?
I've been in the Cassegrain. Yeah, I've ridden in a prime focus cage.
Okay, I've heard stories of things that happen in there sometimes, and different things. People dropping food, people doing this, people doing that. And they're always funny.
Yeah, there's all sorts of stories. My favorite story isn't from the front of the telescope, but it's a grad student that got stranded at the back of the telescope, out of balance, kind of hanging upside down. But what stories have you heard? I think you've heard
Nothing
the good
I'd
one.
repeat here. Just curious.
Okay.
Cassegrain cage? This is some
prime focus cage.
Or the prime focus cage, yeah.
Yeah, so Cassegrain is where the grad student I knew got dangled. That's the back end of the telescope where you don't get yourself in as much trouble.
Yeah,
but to get to the prime focus cage, you have to climb up the inside of the dome. You're now 2 stories up off the ground. You have to somehow get into the front of the telescope. And then it makes a Mercury capsule look like a big roomy space. And you're in there as the telescope moves around, and it's all very terrifying, yet awesome.
Well, I think we... I don't know. Should we go back to M33? Where have you taken us back to?
M42.
You're back to
now,
Orion.
I've got 1 second, and the gain is set to 0, and you can make out the center stars a little bit.
Is that the trapezium?
Yeah. Let me get it into view.
Now, Roy, can you get a view of Mars?
No, it's not up yet.
It's not up yet for you. Really?
It'll be in a couple hours.
Yeah. Okay. All right. Well, then we'll just have to wait for it, won't we?
Yeah, I'm for it.
I actually have to go. Oh, it's a nice shot.
You can tell my focus has drifted a little bit. That's the other problem with a fast scope is focus is much more critical. And with temperature, I change a lot.
And so, do you have to focus it manually, or can you focus it from...
I've got in here, this is my control for my focus. You can see that. So I can go in and out. But it's tedious. And let me just get a longer exposure here. And we'll take a look at this guy. Especially when you're looking at a nebula, the focus isn't that critical. But you can see how the stars starting to look like little crescents.
Yeah. Yeah.
But I do have to run.
All right. Well, thanks, Phil.
All right.
Phil,
thank you all.
Thank you very
all
much.
You brought your telescopes and are doing this. This is tremendous what you're doing.
Yeah.
Bringing this to it's just amazing.
I'm just happy to be part of it. Thanks a lot.
See y'all later.
Me too.
Bye.
See you.
Right. Hey, Gary, how about
Yes.
M33?
Yeah. Why don't we close it out on M33?
Okay.
It's relatively large and it's pretty bright, so.
Well, you had it at the
Might
beginning.
be
Oh,
able to
M33, or not M31. Okay, yeah.
M33 is the triangulum
Do
galaxy.
you want me to try and get Mars then?
If you want to get another view of Mars, that would be great, David.
Okay.
That's Saturn. I hate to say goodbye to that Saturn. Let me get one last view of it for everybody. Oh, look at that. That is a phenomenal view. You have an amazing telescope as well, David, and I know it's a smaller telescope, but you've really got a good view. Good solid mount on it. And what's your telescope, David? Oh, well, they're falling off now. We're losing them one by one.
Oh, I was on mute again.
Oh, yeah.
It's a 6-inch Newtonian Celestron, aren't they?
And so, what would one of those telescopes cost? That's not very expensive.
That was £300. So
Yeah.
I guess it's about $450 in US dollars.
Yeah, so about a $500 telescope. Did that include the mount?
But well, this is a new mount that I bought for it because the one it came on is the manual mount.
Yeah, and I mean you've been tracking really nicely, so it's got to be a pretty nice mount.
Yeah, this is a Skywatcher EQ6.
And how much did a mount like that set you back?
That was about £900.
That's the
So
same
you
mount I
actually
had.
Yeah, so you spent more on the mount than you did on the telescope itself.
Yeah.
Yeah.
It's a really nice entry quality astrophotography mount if you're going to really try to do astrophotography. It's kind of the lower price. It's sort of similar to the Celestron CGE mount, kind of the same level, and its weight limit is about 40 pounds. But it's a nice mount.
And then what are you using for your camera, David?
It's a Philips webcam.
It's just a Philips webcam. Oh, like a 2-cam.
Yeah, it's the SPC 900.
Oh, it's a
So
beautiful view.
I think that's the next one they made after that.
Yeah. I mean, this is like an out-of-production camera that people keep buying, right? Just because it works quite
Yeah.
well.
Yeah, that's right.
It's amazing how this happens over and over in astronomy. Is people start creating something that just happens to work perfectly for our community, and we glom onto it, and then they move on to the bigger and better thing. But we want that original. And so this is where places like Astromart end up doing an amazing business in used goods.
Yeah, so these cameras are pretty terrible, like webcams for most people. Like it doesn't compare to the webcams that we're using, but for astronomy, it's phenomenal.
And that's what I love about Saturn is when you take your scope out somewhere and people go, hey, take a look at this. And they, no, that's a picture you put on the front of the scope.
Yeah.
That's not real. Okay, you want to take a look at that 42 and then I'll move over to 33?
Yeah, that'd be great. That'd be great. So David Moulton wants to know how many people, if there's a way to know how many people are watching. No, there is not. We have no idea.
One.
Yes, the way we get some rough idea is if you +1 it. So if everyone who's watching can click the +1, then we'll get a sense of how many people are watching.
I took my telescope to a star party once at an elementary school, and a kindergarten looked in it and said, "Hey, Daddy, there's a circle around that." She was talking about Saturn.
I can just imagine when Galileo pointed that scope up and saw the ears on this planet.
Yeah, phenomenal. So David, you're gonna try and get Mars in view?
Yeah, okay, I'll do that now.
Yeah, that'd be great. Thank you.
Okay, you want me to go to M33, or you want to look at the Orion real quick again before I move?
Let's look at Orion here one last time. So here, everyone who's watching, if you joined us late, here's the Orion Nebula.
And can we do a round robin of where everyone's located again? I see people asking that in the comments.
So Roy is in Arizona right now. Actually, he lives in Las Vegas, but he's set up in Arizona. Gary is located in the Los Angeles area, and David is in England. And so this is David's view of Saturn, although he's going to be moving to Mars in a second. And that's Gary's view of the Orion Nebula. And there's Roy's view of Jupiter.
And for those who are following in Twitter and who can't +1 us, if you can drop us a tweet, it's free and it will help us get statistics. And there's that infamous binning that we've been talking so much about.
Yes. Oh, I forgot that showed up there.
So 3 by 3 means you take 9 pixels, so you have 3 pixels across the bottom, so choink, choink, choink. And then you have 3 pixels up, and this makes a 9 by 9. This makes a 3 by 3 grid of 9 pixels. You combine all that light down to 1 pixel. So you get significantly lower resolution. But all the light that hit those 9 pixels all comes together to allow you to very quickly gather a lot of light.
Okay, and we are exposing. Let's see.
Hey, Fraser, has anybody got through that's has a solar filter on their scope yet?
No, I've had a couple of people who have offered to do it, and John actually had a view of the sun, but he was having a lot of trouble with his webcam. So not yet. I'm still waiting for someone to be able to show the sun.
I hope to get a solar filter for this 8-inch here in the next month or so. So hopefully I can on some weekend or something during the day, if it's clear, I can try it. I've never tried it.
Yeah, Fraser, I have one, but it's not a hydrogen alpha or anything. It's just a regular like 1% solar filter or whatever it is. And we can see sunspots, and that's about it.
Oh, that'd be great. You know how I roll. Yeah, I'm ready at any time to jump in a Hangout and go live and display this on the internet. No problem. All you have to do is just let me know you've got a view.
The one I was looking at was the one that Stuart, that goes over the top of over the front of the telescope.
Yeah, I built mine. I just got some film, some Bader film, and then just sort of custom built a hole and I just plop it on the top of it. You can do it for really cheap.
Okay.
I'll send you the information of the film.
Yeah, I'd appreciate it.
Sure.
Yeah.
Okay, that's M33 with the 30-second, and I'm doing a 2-minute exposure right now to see if we can dig a little more out.
Yeah, and again, for anyone who's watching, if you have a telescope and you want to participate, all you have to do is drop me an email. Just drop me an email at info@universetoday.com, or you can sort of message me through Google+. And if you can get a view from your telescope onto a computer screen, then the rest of it is really easy. If you're using Windows, the best software that we've all agreed on right now to do this is a piece of software called Webcam Max. And what that does, that lets you turn a chunk of your screen into a virtual webcam that you can then display into the Hangout, and that just looks phenomenal. So yeah, I've seen a couple of people say they can do it. So all you have to do is just drop me an email, and then we'll go into a Hangout and sort of do some tests and see if it works. And if so, then I'll add you to my list of people to invite. And then we're going to try and move to doing these on a more scheduled basis. So we'll actually pick like one time in the afternoon or evening for my time, and then maybe one time in the morning, and just get people from different parts of the world all at the same time. I mean, in my dream world, it's it's a couple of astronomers and then 8 telescopes. That's the plan.
So what's working on resolving itself is a very, very faint face-on spiral. So hopefully it will surprise us all with its existence in this next image. Oh, starting to maybe. There.
There it is. I see it.
So you can actually sort of make out a turned sideways letter S, or an integral symbol.
There, that's it. Perfect. Right there, Gary. Write this down.
And this is just a beautiful, very, very open, very, very diffuse spiral galaxy. It's one of my favorites.
That's phenomenal.
Now, just for reference, when I shoot that, I usually use a 10-minute exposure, and I'll do 6 to 12 exposures with each filter.
Yeah.
Wow. What have you got as an exposure right now? Is this a minute?
2 minutes.
You're doing a 2-minute exposure.
And you bend it a lot, so I'm assuming when you're doing astrophotography you don't do any bending.
Absolutely, yes. Yeah, I want the full res.
Can we try unbending just to see what it looks like?
Do you want to see it? Sure.
Yeah.
I'm surprised that F2 took so long. I was thinking it was bright enough that that F2 should have pulled in that light a lot better.
Well, you can see the, if I'm up, this should show you the histogram. And this is what I adjust. So I've got it set, I'm looking at just this part right here. And you can tell I'm in light polluted because I've got so much that doesn't hit dark. Okay, you want to see one by one.
Can you just pull up one of the images that you took in the past, maybe?
I can.
That would
get
be
this
awesome.
one going.
So Rob wanted to know, so Rob Walker, yeah, you're asking how to contribute, that it's a more exclusive group. No, if you have a telescope that is able to stream a view from your telescope and you can track, then we'd love to get your help. Anybody who has the ability to join us, that would be phenomenal. And
this is something that we're trying to do with everything we do, is to make it completely open. So open science, no walls, make it so that everyone out there who wants to participate in science actually can. So all of our software, if you want the software to do the Hangouts, give me a couple of days to fix a couple of bugs that I discovered this evening. The software is available on our website. We're going to, everything we do, we want you to be a part of it.
So there's David's view of Mars again, and once again, that's just phenomenal.
I love one of the comments that we just got in Google+. Selena, whose last name I'm not sure I will ever pronounce correctly, just asked if he was the only one enjoying breakfast while watching the Hangout. No, I don't think you're the only one. But it's great that Southeast Asia is in the Hangout.
So there was the M33 that I took compared to what his was.
Oh, nice. So that was a photo that you took a few nights ago.
Yeah, that was 10-minute exposures through my F6 stacked all night long. So.
And that's pseudo color.
Well, yeah, I guess you could call it. It was done through red, green, and blue filters, but I probably got it messed up a little bit.
You guys are cheating now.
Just showing the pictures.
Yeah, I know. Come on.
You have to do something during the exposure time.
I guess so.
Absolutely.
Yeah.
Let me get this down to size here.
Hold on. I'll get some pictures from the Hubble Space Telescope.
Would you please?
I just took this the other night. Yeah.
Let me get this in frame.
Oh, fantastic. So that's sort of the final result of this.
Yeah.
Oh, that's beautiful.
And this particular one was from a dark location, so I could use red, green, blue filters rather than the narrow band.
I just love how you can see all the pockets of star formation all throughout the arms.
Yeah.
That's beautiful. All right, I'm going to go back to this Mars image because it's just fantastic. And it's live. It's real.
So Austin is asking in the comments, how could I track the sun during the day with the CPU tracking system? I'm not quite sure what you mean by a CPU tracking system, but the sun actually, for the most part, you can use any telescope tracking system and it will happily keep the sun mostly within your field of view. The sun does move at a slightly different rate than the stars, but it's not enough that you'll notice it during just looking at it with your eyes. So you do need a filter. Do not look at the sun unless you have either an H-alpha filter or a special neutral density filter designed just for the sun. We love all of you and do not want you to destroy your eyeballs.
Yeah.
And in firsthand, one of the guys in my club burned a hole right in the center of his retina by accidentally looking at the sun.
Oh, I ruined a pair of binoculars.
I set carpet on fire. I was projecting sunlight through a 16-inch telescope.
Okay, there's 2 minutes unbin, Fraser.
All right, hold on. Yeah, well, you can. I don't know. I like this too.
Yeah, my focus is significantly off right now, but you know, the way I get exposures and look at it to do a good focus takes 5 or 10 minutes.
Yeah.
So David Moulton is asking, it seems like some mounts can track at the solar rate. Yes, in fact, you can buy telescopes that have programmable tracking rates. And this is what the people who are looking for Kuiper belt objects, who are imaging satellites. There's actually mounts out there that you can have them track at satellite rates, which is really stupid fast. But you're adding money every time you add a view.
Yeah, I had an offer from somebody who was going to try and track the International Space Station during one of these.
That would be awesome.
Yeah, won't that be amazing?
I tried once, but my scope was too slow and my camera wasn't fast enough.
Dexter Southfield High School in Massachusetts has all the technology to do that, and I know their lead observer, Mark Kozabal. I'll talk to him.
Very cool. All right, well, I think we're starting to wind this down, so why don't we sort of take one last view at what everyone's seeing. There's David's view of Mars, and David has been David's got sort of quite a loud mic, so he hasn't been able to talk as much, but he's been delivering these solid views of Mars and Saturn all night long. So I just really appreciate his participation. That's fantastic. And then of course Gary's phenomenal monster telescope with its crazy camera pointing out the front, which is just quite a unique setup. So that's fantastic. Thanks a lot, Gary.
Yeah, very welcome.
I think
I thought I'd end it here with a Death Star.
Oh, wow. That's just kind of ominous.
Yeah, that is super ominous. Oh, there it is. Yikes.
And there you're seeing the infrared camera reflected in the mirror.
It's phenomenal. And there's Roy's beautiful view of the moon. That's just fantastic. All right, and then Stuart, you got clouded out, but hopefully we'll get some of your beautiful planetary views next time.
Yeah. Pamela, is the software you're talking about on the CosmoQuest website?
For the Google Hangouts?
Yes.
Yes. If you look at a blog post I put up a few days ago, it's all attached and there's documentation. Now I discovered tonight that the comments dies after 100 comments, so give me until Monday and then I'll have a bug fix deployed.
I think they're going to try and Jenny was mentioning from Google. She's mentioning they're going to set up the API so you can view the comments flipped and pull them out the other way, as opposed to having. So I think we're going to talk about that tomorrow and sort of see where they're at. So. But
all of our software goes out on our website, and as it goes live, I blog about it. So you can subscribe to our blog at cosmoquest.org/blog.
Sweet. And unfortunately, the best place to announce this, we announce this on Twitter usually. But if you want to sort of watch this in the future, just make sure that you have me circled, just because I'm the one who usually starts up the Hangouts, and that way you can do it. But of course, you should circle all of these other wonderful people as well. Well, thanks again, Pamela, for jumping in and providing the science. And thanks to everybody who was watching. Again, if you're watching this, if you can +1 it, that would be amazing. Now, the next thing that we're going to do is on Thursday at 10 a.m. Pacific time, we're going to do our weekly space hangout where we have our collection of space journalists talk about all of the interesting stuff that's happened in space and astronomy news this week. And that's at 10 a.m. Pacific, 1 Eastern, 1800 Greenwich Mean Time, and I'll let you all calculate the
Like
rest.
7 a.m. Sydney.
Yeah, I don't even try to guess anymore.
And we put out a post every Friday on the CosmoQuest blog listing all of the stuff coming up for the next week and all historical events as well. So another reason to follow our blog.
There you go. All right, well, thanks again, everybody. I'm going to shut down this broadcast now. Thanks to everyone who's watching.
Before we disappear,
Thanks.
I want to thank everybody in the chat room. We were just looking through the comments. And Pamela, I have to say I'm slightly disappointed in you that you took a horse over his telescope.
You know, a girl has to sometimes step away from the keyboard.
I guess.
All right.
All right,
Thanks, everybody. All right, we'll see you next time.
Thanks, everyone.
Thanks.